Hello everyone, my name is Rujan, and today we are going to see Azure Virtual Machine Scale Set Autoscaling Web Architecture mini project. So in this project, let me tell you the architecture of this project. So basically, as you can see in the screen, we are going to define one public IP. All the traffic which will come from internet, it will reach to this public IP, and we will define this public IP to Azure standard load balancer. In that load balancer, we are going to define a HTTP pro, which will check the health check of bad instance, then load balancing rule, backend address pool. We will define in this load balancer, and this load balancer will travel to virtual machine, which is defined in Azure Virtual Machine Scale Set. So here we are going to define Azure monitoring at a scale. So basically, when the CPU utilization goes beyond the specific threshold, it will scale up. And if the CPU utilization is idle or it is less than the threshold, it will automatically scale down the virtual machine instance count. So in that, we are also going to define some network security group. It should allow port 80, port 443, and port 22. Actually, port 443 is not necessary. Only we are going to use port 80 and port 22. So yeah, so let's get started and let's check out the code. Okay, so let's check out this code. So this is our directory where all the .tf files we have created, like provider.tf. Here we have mentioned Azure RM provider and HashiCorp version details. Then this is our Terraform TF state. Then local, which are the variable values which are we have mentioned here, like port 3 and 22. This is Azure public key, and this is our main code. So let's go one by one resource. So this is our Azure RM resource group, and obviously we need to mention the virtual network as well as the subnet in it, and we need to mention what are the address space. So here we have mentioned /24, so almost 256 IPs we can use in this subnet. Then yes, we need to define public IP, load balancer, and in that load balancer we need to mention the same public IP. So whichever we have defining the public IP, same IP should be applied to this load balancer. So whenever user load that public IP, it will automatically goes to load balancer public IP. Then here we need to define what is the scale up configuration and scale down configuration. So as we can see, we have defined the capacity. Default, there should be one instance. Minimum also one instance. Maximum, it should go up to 3 instances. And these are the rules. Like we are going to scale up and scale down according to only CPU utilization. We can define for memory also. So just for this video sake, we have mentioned the CPU utilization, the CPU load is 1%. Usually in the corporate field, we mention 75%, 70 or 85. But for this video sake, I have mentioned only 1, so we can clearly see the changes of the scale up and scale down virtual machines. Okay, these are the rule for scale down. If the CPU utilization is less than 0.20%, it will be automatically scale down. So whatever the multiple virtual machine has been created, it will scale down to one virtual machine. Yeah. So it is the predictability to look ahead of the time up to 5 minutes we have defined. Okay, and these are the notification and alert. I have disabled it. Okay. Yeah. So this is the association where we tie up the security group with the defined subnet, and these are the security group. As you can see, the interesting part here is we use dynamic and for each. So basically, to define network security group, instead of multiple same code, we have using for each, so that it will look around this for each, and it will create 3 multiple inbound rules, like for port 22, port 80, and for port 443. And the next and the core part of this code is virtual machine scale set. Here we are going to deploy Linux machine. This is the VM size, or we can say VM image, and instance obviously one, and admin user as our user. We are going to use SSH keygen, and with the public IP and private IP, we are going to log in into our virtual machine. Yes, this is the main part. So to load the web application when the virtual machine is getting boot, we are going to use cloud init, or we can say custom data, and it should be base64 encoded. So let me show the user data to you. Yeah, so whenever the virtual machine is getting created at the boot time, it will automatically execute this command. In this command, it will automatically patch the virtual machine as well as install Apache and PHP applications also. So this code will automatically load into the virtual machine as soon as it is getting deployed. Yeah, these are the OS days and network interface. OS days we are mentioning SSD premium. IP configuration we are mentioning here. Its virtual machine should be in the same subnet which I have deployed. And lifecycle, we have mentioned lifecycle to ignore changes. So basically, when the scale up and scale goes down, it will automatically change the instance. If the scale up, instance may increase. If the scale down, instance may decrease. So there will be a lot of changes. That's why we are mentioning to ignore the changes. Yeah. So this is also important part here. We are mentioning the backend address pool. So whenever the traffic hits the public IP and load balancer, whatever the backup address pool, we need to define here. Yeah. Then Azure LB Probe, it is basically health check, like whether the backup IP, or we can say backup instance which we are sending traffic, it is healthy or not. If it is healthy, then we will keep sending the traffic to same virtual machine. If it is not healthy, it will automatically send traffic to different VM. Yeah, so obviously to send traffic, we need to allow some rules. The port 80 should be allowed to check the HTTP probe, and outbound rules should be defined. And we have mentioned the protocols to all instead of only TCP. So TCP will restrict some of the data, but for outbound rule, we need to mention all. Just make sure to inbound rule, it should not be all. It is a kind of security breach. But for outbound rule, we can say it all. Okay. So yeah, let's get started. Let's just create this all the resources in our Azure account. Yeah, Terraform plan. So it will check our current status in Azure portal. If the current status and our current code is matches, then there will be no changes. But if there is a change, it will just mention here, and after applying that change, it will apply to the portal. And here we are sending our .uat variable files. So as I showed you, these variable will pass on to main.tf. So instead of mentioning everywhere, if there is a variable, we can define it here, and it will be automatically passed to the same main code. So you can define multiple variables, and that multiple variable we can pass into the main code. Okay. So let's run this. Yeah. So our code has been executed and all 13 resources has been added to our Azure public cloud. So just to verify, let's just open our public Azure portal. So as for now, there are no resources. Let me just refresh it. Yeah, now you can see all the resources has been deployed: the load balancer, virtual network, network security group, public IP, virtual machine, scale set. Now to load our web page, we need to open that public IP in the URL. So let me just click on public IP. Yeah, this is our public IP. Let me just open it in incognito window. Enter. Yeah, we have defined HTTP. That's why the warning. Yeah, so this is our Azure virtual machine scale set live monitoring web app. The current visitor count is 1 and it is running on 00001 instance, and this is the MAC address of that instance, and current CPU utilization of that instance is 0.7, which is still less than our threshold. So let me just refresh it. Yeah, it is 0.9, still less than our threshold. Yeah, as you can see, it is crosses our threshold, and as you can see, but the virtual machine instance is still same. It is still 00001 and MAC address is still same. You might be thinking, "Okay, we have already crossed the threshold, but still the CPU utilization did, also crosses, but still the virtual machine instance is the same. It should be different. Like load balancer should route the traffic to the next instance, right? But if you see my code, yeah, this is the code. So let me see where it is. Wait a minute, not this code. Yeah, this is the rule we have defined. So here, as you can see, time window we have mentioned 3 minutes. So if the CPU utilization should cross the threshold of 1%, it should remain for 3 minutes. The CPU utilization should remain ideal for 3 minutes. Then and then only virtual machine scale set will deploy another virtual machine and the traffic will route to that virtual machine. So let's just wait for 3 minutes. Hope the CPU utilization will remain the same, not decrease. Yeah, it is keep on increasing. That's the good news. So for 3 minutes, we need to wait here. Let me just keep on refreshing. Or let me just pause this video. Or we can wait for 3 minutes, no issue. If you want to see this live, we need to wait for 3 minutes. Hope you can just keep the video. I will just click on refreshing. As you can see in the notification, we have also configured the custom emails to this mail. So let me open my mail also. Mail. Wait, it's in incognito mode. That's why. Wait a second. I will open in my logged in browser. Mail. Hope 3 minutes are over now. Yeah, as you can see, the instance name has been changed. It is changed to 0002, and the MAC address is also been changed, and the visitor count also got reset. That's why the visitor count is 2. And if I check the email address, I think we got an alert for that also. As you can see, yeah, Azure monitoring has been scaled the UAT virtual machine scale set resources from capacity of 1 to capacity of 2. So basically, it is saying you had one instance, now it is running on 2 instances. So yeah, this is the project.